Welcome back. I have kind of missed making these videos and just hearing from you guys over spring break. I hope you had a great break and some time to just relax and not think about school at all. I know I didn't think about school at all. I just pretty much I painted my house. I rescheduled my wedding. For those of you that were wondering, I know a few of you reached out to me and asked, which was really sweet. But yeah, we had to reschedule it to August. So hopefully, I won't be Miss Jackson next year. So hopefully, this whole virus thing doesn't make me push it back anymore. Otherwise, I might be Miss Jackson for a little bit longer. But yeah, so really this quads unit is really close to being through. I think we're only going to do these notes, a little bit more practice, and then we'll talk about trapezoids, but I don't think I'm going to go as in depth as I would have if we were in class per se. So today I'm going to do this is kind of a lot of review, I think, almost, and we're just using everything that we've learned the past week or so. So hopefully you checked out, I put up this page. This is a reference sheet, okay? This is the sheet that I would always make a really bright color so you wouldn't lose it. I would try to make a sheet as close as possible to this one. That way you have it on hand whenever you need it. Right now you don't need this part. We haven't even talked about triangle or trapezoids yet, so don't worry about any of this. The big thing are parallelograms, rhombi, rectangles, and squares. So if you want to leave some space for this later, you can, but really all you need are these four. The way this works is parallelograms, they're like the parent almost, they're what all of these come back to, I should say. So the rhombi and rectangle, they have all of these qualities as well as these additional ones. So that's why they're connected. So even though the rhombi has these three properties, you can't forget about these as well. So maybe make note of that somehow, that's why these should be connected, okay? And then the same goes with squares. Squares, they tell you down here, squares have all the properties of parallelograms, rectangles, and rhombi, so that's why it's all the way at the end. I could even make a line that goes all the way down here too. So if you want to take a minute and kind of make this sheet as pretty as you want. And I do want to say that the sheet that we're working with today, it has kind of a notes part at the top, and you could actually add these, the parallelogram case, opposite sides are not congruent and diagonals are not congruent. It kind of mentions that in this thing, but it doesn't say it as explicitly. So it says opposite sides are congruent here, but it doesn't say diagonals are not congruent. It just doesn't mention that diagonals are congruent at all. So you're supposed to assume oh, they're not congruent. So maybe off to the side you could put reminder, diagonals are not congruent. I'm sure you can make it look a lot prettier than this by just adding some more room for each box. But it's completely up to you if you want to make this sheet just as it is on Canvas, or if you want to add in this stuff from the notes as well. So really the only notes for today per se, because this reference sheet is just for you guys to keep everything in one sheet. That way you're not having to look back at all of these notes that we've taken. So today, this will be the new stuff kind of, but we're basically taking all of those cases, all of those properties, and using coordinate geometry to kind of guess what this mystery quadrilateral is. So the two steps that you need, I'm going to make sure my pen is really tiny. So we're trying to figure out by just having coordinates what type of quadrilateral this is. So the first step, you're going to check the congruency of sides, okay? And whenever you're checking congruency, that means you're using the distance formula. So I'm going to write that somewhere in a second. The second step is to check the congruency of diagonals. So knowing the difference between all four of these quadrilaterals and which ones have congruent sides and which ones have congruent diagonals versus like which ones do not and which one, like you'll see down here. So case 1, a parallelogram, opposite sides are congruent, but the diagonals are not congruent. So again, what it means by opposite sides is we could say this side, that is really big, and this side are congruent, and then possibly these two opposite sides are congruent, but we can't say that about the diagonals at all, okay? So if you want to kind of mark up these pictures, if you are making the notes look just like this. Then for case 2, in a rectangle, opposite sides are congruent and the diagonals are congruent. So I'm going to kind of just highlight the diagonals since I can't really make them congruent signs as pretty. So those two are congruent, but then specifically the opposite sides, I'm going to do it like this. Okay, and the part that's the opposite sides is really important because when we get down to rhombi and squares, then they get into that all four sides are congruent. So if all four sides are congruent, then we would just show this. And in a rhombus, the diagonals are not congruent, so I can only say something about the sides. But then a square, all four sides are congruent and all the diagonals are congruent. So I would have something like this. Okay? So like I said, just having this reference sheet out is a very good idea, and then adding these different cases to that reference sheet might be a good idea. However you think it will be best. I know not everyone's able to like print all these notes out, so however it's more organized on your end, that's completely fine with me. If I were you, I would make it look as much like this one as possible though. So I'm going to do just problems 1, 2, and 3, and then you're going to do problems 4 and 5 for homework and to like turn in today for attendance, okay? And I'm hoping these will be pretty easy. The last time we used the distance formula, everyone was doing pretty well with it. So hopefully you found like a calculator or some sort of way to calculate these distances pretty well. Oh, and I was going to put distance formula. So here's distance formula if you've forgotten. D equals the square root of x1 minus x2 squared. So you're going to square that difference. And you're going to keep whatever this is, whatever this distance is, or difference. If it's a negative, make sure you keep that negative in the parentheses. Otherwise, it's going to screw it up, okay? If I keep going, so plus parentheses y1 minus y2. Doesn't matter what order you go in for distance formula. It's completely up to you. Just keep your x's and your y's separate, I should say. All right, so for number 1, I'm not going to go through adding and subtracting. I'm just going to kind of like set up where the points would go, and then I'm going to actually like cut the video so you're not just watching me do all of the typing in my calculator, that sort of thing. So reminder for coordinates, I have an x and a y coordinate. My x is what comes first and my y is what comes second. Since I'm working with this quadrilateral A, B, C, and D, I'm just going to kind of make like a rough sketch of what that might look like. I don't know exactly what kind of quadrilateral it is yet. So first, my first step, step 1, is to check the congruency of the sides. Okay, so that means I'm going to check with AB and DC and AD and BC. See if those are congruent. Or if all 4 of them are congruent. If I see that all 4 of them are congruent right off the bat, then I can narrow it down to a rhombi and a square. Okay? So, with AB, here's AB, I'm going to have D equals the square root. X1, my first point I'm going to use is A, so this is like point 1. and this will be 0.2. So my x1 would be 9 minus 8, because that would be my x2 point, squared, plus -4 minus -2. Now when you have minus minus, that turns into a plus. So try to figure that out and then tell me what you get. Okay, so hopefully you got AB equals radical 5. If not, go back, check your algebra, how you put in your calculator, making sure that you put in -2 parentheses squared and not -2 squared. Okay. Also, I forgot to put AB equals. So the next one I'm going to check is DC. This time, x1, I'm going to make it 2. Doesn't really matter. You could have started with 3. Plus -5 minus -7. Again, I have those two negatives right next to each other, so that turns into positive or a plus sign. I'll wait for you to check what you get. Hopefully you got -5. So then next for, let's do AD. So AD equals radical 9 minus 3 squared, because now I'm using points A and D. Okay, so that's where my points are coming from, A and D. 9, X, 9 and 3. Plus -4 minus -7. There's another double negative that turns into a positive. Don't forget to square. And AD is square root of 45. So then last one would be DC. Oh wait, no, I already did say DC. BC. So BC, I'm going to take radical 8 minus 2 squared plus -2 minus -5. And square that. So again, -2 minus -5 turns into -2 plus 5. And that is also the square root of 45. So, okay. Right now, pause. Well, not really pause the video, but just let's pause and think. So I showed that these two pairs of opposite sides were congruent and that these two pairs of opposite sides were congruent. I did not show that all four sides are congruent, so I can already say that this is not a square and it's not a rhombus based off of just these cases. So the only way for it to be a rhombus or a square, I would have to have all four sides be congruent. I already showed that's not true. So the only two shapes I'm dealing with are being a rectangle and a parallelogram. So, in order to distinguish between which one of these it is, I'm going to move on to step 2. So step 2 is where I'm going to compare the lengths of the diagonals. So the two diagonals I have, this is where you have to really be looking at your picture because sometimes it can be hard to visualize in your head. But you need AC and DB to be congruent. If those two are congruent, then you're going to say it's a rectangle. If they're not congruent, then it has to be a parallelogram. And that's coming straight from these cases up above. Okay? So step 2. I'm still going to use the distance formula. And I'm actually going to have you calculate it this time. So AC and DB. So pause, try to figure it out, and then come back. For step 2, hopefully you got radical 50 for both AC and DB. So that shows me that my two diagonals are congruent. So that has to mean that this is a rectangle, okay? So we prove that opposite sides are congruent and the diagonals are congruent, which is just what case number 2 says. Opposite sides, diagonals are congruent. So we would say ABCD is a rectangle. All right, I told you I would do 2 and 3 with you. If you want to try 2 and 3 on your own and just try to fast forward to whatever I say it is, that's cool with me. Just do as much as you need to learn this concept today, okay? So starting off, I always like to draw a picture just so I know what I'm dealing with. Something like QRST. So I want to show that possibly QR and TS are congruent, and then RS and QT are congruent, or that all four sides are congruent. So step 1 is to start with the sides. So when I find QR, I'm going to have -2 minus 1 squared plus -7 minus -5, which turns into +5 squared. So then I get radical 9 plus 4, which is radical 13, with ST. My hunch was correct. So far this is showing me it's going to be a rhombus or a square. Okay, I don't know which one yet, so now it's time to check the diagonals. The diagonals are going to tell me which one of those it is. So I need to find QS and TR. So QS, you guys are going to be pros at the distance formula. -2 minus 4 squared plus -7 minus -7, so +7 squared. Okay, these actually cancel each other out, so it becomes 0. So then we have -6 squared, so this turns into radical 36, because 6 squared is 36. Then I need to find TR. TR would be radical 1 minus 1 squared, which those are going to cancel out, giving me 0 there, plus -5 minus -5, but plus 9. And -5 plus 9 is 4. So that turns into 4 squared, which would give me 16. So this is radical 16. Which, if I actually simplify these, I could to be 6 and 4. 6 and 4 are not the same number, so that shows me that my diagonals are not the same. So the only quadrilateral where all the four sides are congruent, but the diagonals are not the same, would lead me to say this is a rhombus. So this quadrilateral is a rhombus. Alright, so I already have 3 kind of set up with my picture drawn, so I'm going to first start with step 1 to show that the sides are congruent, if at all possible. So I'm going to start with JK. So JK, I got the radical 18. One thing, if you are getting decimals, like you're just putting this straight in your calculator, like that's completely fine for right now. I understand like not wanting to do all the mental math. So I'm fine if you're using a calculator right now. But I just think the radicals are a little prettier than having like a never-ending decimal. So that's why I'm doing it. So for LM, I would have something that looks like this. And I also get radical 18. So already that's a good sign. Next, I'm going to check JM and KL. I get radical 9 plus 64, which turns into radical 73. And then I'm going to try KL. So already I know that this is not a rhombus or a square because this is not radical 18, and these would not be all congruent to each other. So I'm hoping for KL I also get radical 73. KL, I also get radical 73, so I have shown that this is going to be a rectangle or a parallelogram just like number 1. Step 2, I'm going to show or try to show that either the diagonals are congruent or they are not. So step 2. So my diagonals would be JL and MK. So JL I'm getting ahead of myself. So JL is radical 36 plus 121. So I get 157 underneath the radical. For MK, I would have this. But 7 minus 2 squared would give me 5 squared, so I have radical 25. So these are not the same number, so my diagonals are not congruent, showing that this cannot be a rectangle and it has to be a parallelogram. So we would say quadrilateral PKLM is a parallelogram. All right, so the next thing I need you to do is to do number 4 and 5 for homework. If you want to go ahead and write down the numbers for both of these problems, but it should be on the document that I put on Canvas. I just want to know what type of quadrilaterals 4 and 5 are. So you're going to tell me, hey, this is a blah, 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 because, and then you're going to tell me like those reasons why. So for number 3, I would have said this is a parallelogram because the opposite sides are congruent and the diagonals are not congruent. Okay, so using exactly what it says for the cases on the very first page. So it shouldn't be too bad, okay? You only have 2 of them to do. Show me you can rock it out with distance formula, and then you have the rest of the day to yourself, okay? Let me know if you guys have questions, and I am still talking. All right, bye guys.